Let's look at worked examples relating to the set theory. The first one says, given that A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and B is equal to 2, 3, 5, 7. Determine A intersection B. A intersection B, and A intersection B means those elements that are in both A and B. 2 is here, 2 is here, 3 is here, 3 is here, 5 is here, 5 is here, 7 is here, 7 is here. Meaning that will be 2, 3, 5, 7. And we can see that since every element of B is a member of A, but not every element of A is a member of B, the implication is that B is a subset of set A. So B is a subset of set A because every element in B is also in A. But B, A union B will be list the elements of both A and B without repeating any. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then part C, number of A union B. We have already A union B. We just count the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements. Then let's look at part D. Number of A complement intersection B. We know that complement means not a member of. So we want those elements that are not members of A, but they are members of B. But we've seen already that every element in B is also in A. So the set of elements that are not in A but in B is empty. There are no elements that are only in B. Every element in B is also in A. So the number is 0. We have 0 elements. Then part E, A intersection B complement elements that are in A but not in B. We have 1, we have 4, we have 6, we have 8, we have 9, we have 10. Those elements are only in A but not in B. Let's look at example number 2. Given that A is the set 1, 2, 3, 4, and then they want us to determine the number of subsets and proper subsets of A. Now, to get the number of subsets, is 2 to the power n, where n is the number of elements of the set, but n is equal to 1, 2, 3, 4. There are 4 elements. 4 elements, therefore we could get the number of subsets. So number of subsets is equal to 2 power 4, which is equal to 16. So there are 16 subsets. Then number of proper subsets will be you subtract 1 from the number of subsets. You subtract the set itself, because we know every set is a subset of itself. So we shall have 2 power n minus 1. Don't write n, the minus 1 as a power also. It's just 2 power n, then minus 1. 2 power, the number of elements are 4, minus 1, this 16 minus 1, which is 15. Example number 3. Given that a is equal to 2, 3, 5, 7, 11, and b is equal to 1, 2, 3, 6, 8, and 10, determine the number of A intersection B, everything complement. This one means those elements that are not in the intersection of A and B. And the easiest way to see these elements is to draw a Venn diagram. So let's put in the elements. We have, this is set A, this is set B. Intersection, those that are both in A and B, we have 2, we have 3, and that's all. Those ones that are in A only, we have 5, 7, 11. Then those ones that are in B only, we have 1, we have 6, we have 8, and 10. So we could count this. This one means members that are not in the intersection of A and B. So those are 1, 2, 3, 4, 5, 6, 7. Though we could first have listed the members. A intersection B, everything complement will be 5, 7, 11. I've listed them in no particular order. 1, 6, 10, and 8. And when we count them, we have 1, 2, 3, 4, 5, 6, 7. So n number of A intersection B, everything complement, will be 7 elements. Next example. The sets M and N are such that number of M is equal to 50, number of N is equal to 25, and number of M union N is equal to 55. Determine N intersection M or M intersection N. And the easiest way to do the number is to draw a Venn diagram. So we can fill our Venn diagram. We know that the total number is 55. We know that the number of those in M are 50. And those in M, N are there are 25. So we shall let this number be something like P. So this will be 50 minus p. This will be 25 minus p. So we shall add them and they will equal to 55. 50 minus p plus p is equal to plus 25 minus p is equal to the universal, which is 55. This is 25 plus 50, which is 75. This cancels, minus p is equal to 55. So p can go the other side and 55 comes this side. You realize that p is equal to 20. So number of m intersection n, which is p, is 20 elements. 20 elements.